last A-level maths video we looked at arithmetic sequences. We're going to look at geometric sequences. So the nth term for a geometric sequence is given by an is equal to a r of n minus 1, where n is the term number, a is the first term, and r is what we call the common ratio. Okay, and hopefully you can see why we have to have an n minus 1 here. It's because a1 is the first term, so but a itself here is also the first term, so we need r n minus 1 equals 1, and that only happens when n minus 1 is equal, well, when the power of r is equal to 0, so we need n minus 1 up to the top. Okay, if we want to take the sum of n terms, so for example you might say I want the sum of the first 10 terms of a geometric series. We take the sum from k is equal to 0 up to n minus 1 of a rk. Okay, that's the sum of the first n terms, and that's equal to a 1 minus r to the n over 1 minus r. So if you're given a geometric series defined by, let's say, an is equal to 3, 2 to the power or n minus 1, then if you get told to sum the first 7 terms, then the sum of these first 7 terms is just equal to the first term a multiplied by 1 minus 2 to the power of 7 over 1 minus 2. Okay, and that's the calculation. You just plug that into your calculator and that'll give you the sum of the first 7 terms. Finally, we are going to look at sum in terms of a geometric series. So this is when we sum up terms of a geometric sequence but up to infinity. So summing up to infinity from k is equal to 1, a r to the k minus 1, and this converges and is equal to a over 1 minus r if the modulus of r is less than 1. Okay, so that's an important condition. If the modulus of r is greater than or equal to 1, then this sum up to infinity of the terms in the geometric series diverges. Okay, so that's important to remember. That's all we're going to look at for geometric series. I encourage you to take a look at a few example questions. In our just main video series on sequences and series, we're going to look at proving this result here. So be sure to check that out, but that's not out just yet. But if you check out the sequence and series playlist, it will be in there soon. If you did enjoy this video, please be sure to like and subscribe. If you've got any questions, let me know down in the comments, and I hope to see you in the next one.